To achieve a higher level of maturity in the digital engineering initiatives, companies should not only automate their engineering design processes at different levels, but also make extensive use of artificial intelligence and machine learning to reduce the simulation turnaround time, minimize prototypes, and speed up the whole design process. At ESTECO, we continue to invest in this direction with our extensive library of optimization algorithms and machine learning-based response surface models. In the engineering community, Python is a useful programming language for building engineering applications and facilitating numerical computation. Also, its machine learning libraries enable engineers to elevate their data analysis effort. Danilo, I see that you have progressively built a Python ecosystem in Mode Frontier to leverage its process automation and design optimization capabilities. How do Mode Frontier users take advantage of this?
Yes, you are right, Dario. Python is becoming very, very popular between our users. So we decided to put Mode Frontier in the context of this Python ecosystem, let me say. The idea was to let our users to use their own Python skills inside Mode Frontier in the most similar way as Mode Frontier native tools. The first tool that we have introduced a couple of years ago, Python-based, is the PyConsole. With the PyConsole, basically you can post-process all the results that you get at the end of the optimization run in Mode Frontier design space by taking advantage of whatever Python libraries that you want to use. PyConsole lets you import the data from Mode Frontier design space tables into a Python environment. And then you can do whatever you want with this data. You can do also the opposite. I mean, from the Python environment, put data as Mode Frontier native tables in the context of Mode Frontier design space. Another very nice, I would say, tool, Python-based tool that there is in Mode Frontier is the PyRSM. The PyRSM lets you train a Python-based RSM in the context of the Mode Frontier RSM training wizard. With the same parameterization, with the same options, exactly as native Mode Frontier RSMs. And at the end, in the Explorer of the design space, you get your Python-based RSM available for visualizing charts and whatever post-processing you want to do at the same level as Mode Frontier native RSMs. Another very useful component, Python-based component, is the PyScheduler. The PyScheduler shares the same concept with the PyRSM, but in this case, it is possible to use a Python-based optimizer, a Python-based scheduler, in the same way as native Mode Frontier optimizers. In Mode Frontier, there is a bridge that lets you use your Python-based optimizer at the same level as Mode Frontier native optimizers. I mean, it will be available in the scheduling project node and also in the planner, ready to be used as an optimization algorithm.
Thanks, Danilo. At ESTECO, making extensive use of artificial intelligence methods also means expanding its usage to a wider audience of CAE engineers. Our numerical team has been working very hard to deliver the autonomous approach to configure our design exploration and optimization algorithms. Could you tell us why the autonomous mode democratizes the use of design optimization and accelerates decision-making processes?
Yes, the autonomous mode is a way to easily parameterize an optimization algorithm in Mode Frontier. You know, Dario, that parameterizing an optimization algorithm can be a difficult task. So in Mode Frontier, we decided to release not only the traditional manual way of configuring the optimization methodologies, but also the self-initializing way to configure it. In the self-initializing mode, you have to just insert one parameter, the total number of design evaluations that you are willing to do for your engineering problem. And on top of this, we decided also to release the autonomous mode. The autonomous mode does not require any parameter to be configured. You can just click and run the optimization problem because the algorithm itself is able to understand the internal structure of the problem by applying some machine learning methodologies, let me say, some machine learning based intelligence inside. in such a way that you get a very good trade-off between the quality of the solutions that you get and the time that is needed to get it. So at the end, you don't need to be an optimization expert to use More Frontier. Your experience in your own engineering domain is enough to be very efficient in design optimization by applying the autonomous mode.
And this is one of the key things for what concerns our technology, because, well, Volta is based on More Frontier technology. And so for whatever it is from the design space exploration technology from More Frontier is also available into Volta. So the planner is available into Volta as it is in More Frontier. As planner is not a piece of More Frontier or Volta, just it is an ESTECO philosophy to decouple the simulation workflow from this design space exploration strategy that you want to apply on top of it. And the autonomous mode is available into Volta too. And as Danilo mentioned, it is a great time saver. It gives you the best trade-off between the quality of the solution and time taken to evaluate it. So in the end, it gives you the best solution in the shortest amount of time.
And yes, also in More Frontier we have a similar concept, I mean the planner environment. Together with the new concept of the planner environment, there is also a new concept at workflow level, because now we have two different ways of configuring the workflow in More Frontier. The traditional one, where you can define both the engineering process, and on the top of that you can define also the optimization strategy graphically. This is very powerful because you have a single view on both the process and the optimization strategy that you decided to use. Together with this approach, we have released a purely process-based workflow where you define only the engineering process, and the optimization strategy can be defined in the planner environment. One of the advantages of using the new paradigm based on the planner and engineering process workflow is that you can define more than one optimization strategy in the context of the same More Frontier project file.
And to effectively scale up the management of multidisciplinary design optimization studies, you need a state-of-the-art web-based orchestration system. How do you address this in Volta?
Well, the scaling up is possible only via web technologies. And Volta was made and was designed for scaling up, for lots of users, lots of disciplines, and lots of simulations. I was mentioning before that one of the problems is to bring every team on board on the same platform. The MDO has many different problems. So MDO is multidisciplinary design optimization. The first problem is the collaboration, because you need to have different teams that collaborate with each other and with their own disciplines, so that each team has its own discipline. And then the problem is that the MDO is complex also for the orchestration point of view, because you have many different single disciplines that you should put together, and those single disciplines, they share different inputs, and some disciplines have the outputs that become inputs for other disciplines. And in the end, you should be able to run those disciplines, and Volta has a dedicated system for running those very complex MDOs directly from the web.